We have done our filtering. We have detected all the pixels which are flooded, and you want to quantify it. Many times it's required to say, I have this flood. I want to compute area for each admin region and say which are the most affected regions. And that helps you quantify and prioritize your relief efforts. So here in the image, you see all the red pixels. These are the pixels that are the final flooded areas, and we want to compute the area. First, let's compute the total area of the region. So in this case, we have a geometry. Let's just compute the total area so we can get an estimate of out of the whole district, how much of it is flooded. So that will be simple. We'll just say geometry dot area, and this will be square meters. We can divide it by 1e4 to get the area in hectares. Say total area is this. So this is the total area of the region. Let's compute the total flooded region. This is the area of this image. We want to compute the area of this image. And as we have done the area calculation before, we need to compute the area of each pixel and then sum them. This is the way to do a raster area calculation in Earth Engine. So we take our total area image, multiply it by e image pixel area. And now this function calculates the area of each pixel. And then we do reduce region to compute the total area within a particular geometry. We'll use the EE reducer sum. Geometry will be the geometry variable, which is the area of the district. Scale, in area calculation, always use the native scale. This is a fairly large calculation, so we want to set the max pixel to a higher number so it doesn't stop. And we also set a tile scale to a higher number so that we can use more machines and can complete this computation. And you can see this is now being computed. It'll take a while, depending on the region, to actually do the computation and print the result. One thing to note is the way Earth Engine works is you can say, oh, why it's taking a while. Earth Engine already knows the flooded area. It's all the pixels, can just sum it up. The flooded area is being computed here, not at 10-meter scale. So right now, what is being displayed and computed is at a different scale. If I inspect this and look at my scale, this is being done at 76-meter scale. So all the analysis is being run on an 80-meter resolution image. And that's why it is done. It is not computed at 10 meter. Now, if I zoom in, it says, okay, I'm going to compute whatever is visible at 10 meter, not the entire image. So that's what I being displayed here. So if I inspect this, this is being done at 20 meters. And that's why if you say, give me everything at 10 meter, Earth Engine has to reproject, resample all the data and run the computation, and you get the final result. So sometimes it'll time out. If it doesn't finish in 5 minutes, it'll time out, but we'll learn how to overcome that. This is how you compute the area. And once it finishes, you'll see the number of the affected pixels. When many people encounter this and say, my area is not being computed, it's timing out, they'll say, oh, let me do it at 100 meters. My analysis will run faster with larger pixel size. I'll get area, but that area will be wrong. Because you can see I got an answer very fast, but this is not the correct area. Because all the other analysis also ran 100 meters. When I said connected pixels, give me 8 connected pixels. Those pixels were also 100 meters, not 10-meter pixels. So my analysis is not correct. So that's why you should always run it at native resolution. What happens if you get timeout? The answer is always export. We need to take this result, convert it to a feature collection, and export. And that's the part of our exercise.